Something is moving through the universe right now. That sounds impossible. A black hole with the mass of roughly 10 million suns has been thrown out of its galaxy and is racing through intergalactic space at around 1,000 kilometers per second. It is no longer sitting at the center of a galaxy. It has no obvious home. It is moving through the darkness, leaving behind something even stranger. A gigantic trail of newly formed stars stretching for roughly 200,000 light-years. And the James Webb Space Telescope helped provide the evidence that turned this extraordinary idea into a serious astronomical discovery. For decades, astrophysicists predicted that supermassive black holes could sometimes be kicked out of their galaxies. But predicting something and actually seeing evidence for it are two very different things. Then, in 2023, astronomers working with Hubble archival images noticed something unusual. Peter Van Dockum of Yale University and his team were examining distant galaxies when they spotted a remarkably thin, straight feature extending away from a galaxy. At first, it looked almost like an artifact. But the more they investigated, the stranger it became. The feature was not simply a line of light. Observations showed evidence of young stars forming along its length. That raised a remarkable possibility. Something massive could have been moving through the surrounding gas, compressing it as it traveled and triggering star formation behind it. And the leading candidate was a supermassive black hole. A black hole cannot be seen directly. It produces no ordinary visible light. So astronomers had to look for the effects of its motion. That is where James Webb became extremely important. Webb observes primarily in infrared wavelengths, allowing astronomers to study objects and regions that can be difficult to analyze with visible light telescopes. When researchers pointed Webb toward the region near the end of the strange stellar trail, they found evidence of a bow shock. A bow shock forms when an object moves rapidly through gas, pushing and compressing material in front of it. You can think of it like the wave that forms in front of a fast-moving boat. Except this boat would be a black hole millions of times more massive than the Sun. The observations revealed a sharp change in the motion of the surrounding gas, consistent with a massive object traveling through it at extraordinary speed. The estimated velocity is around 1,000 kilometers per second. That is roughly 2.2 million miles per hour. And the suspected black hole could contain around 10 million solar masses, with some estimates allowing for an even larger mass. For comparison, Sagittarius A*, the supermassive black hole at the center of our Milky Way, has a mass of about 4 million suns. So this runaway object may be several times more massive than the black hole at the heart of our own galaxy. And yet it is no longer sitting at the center of a galaxy. It is moving through space. The stellar trail associated with it is enormous, stretching roughly 200,000 light-years. For comparison, the Milky Way itself is about 100,000 light-years across. That means this trail could be roughly twice the diameter of our entire galaxy. But how does something this massive escape from a galaxy in the first place? The answer may involve one of the most chaotic gravitational situations imaginable. Galaxy mergers can bring multiple supermassive black holes into the same region. As galaxies collide and merge, their central black holes can gradually sink toward the new center through gravitational interactions with surrounding stars and gas. Eventually, multiple black holes can end up interacting in a very crowded environment. And when three massive black holes interact, things can become chaotic. This is known as the three-body problem. With two objects, their gravitational motion can often be calculated precisely. Add a third object of comparable mass, and the system can become dramatically more unpredictable. One black hole can potentially gain enough energy to be thrown outward while the others remain gravitationally bound. It is essentially a cosmic gravitational slingshot. Another possibility involves gravitational-wave recoil. When two black holes merge, the gravitational waves they emit can carry momentum away asymmetrically. If the conditions are right, the newly merged black hole can receive a powerful kick. In extreme cases, that kick can send it racing away from the center of its galaxy. In the case of this runaway black hole, researchers have considered both mechanisms, with a complex three-black hole interaction providing a compelling explanation. The host system itself appears to be the product of a galaxy merger. That means the environment may have contained exactly the kind of chaotic gravitational conditions needed to eject a massive black hole. And this discovery raises a much bigger question. If one runaway supermassive black hole exists, how many more are out there? Galaxy mergers have happened throughout cosmic history. Massive galaxies have collided, combined, and reorganized countless times. If even a small fraction of those events eject their central black holes, then intergalactic space could contain a population of wandering black holes that are extremely difficult to detect. And that is the terrifying part of the astronomy, not because these objects pose a threat to Earth, but because they could be almost completely invisible. A black hole traveling through a region with little gas would produce very little detectable light. Without surrounding material to interact with, astronomers might have no obvious way to locate it. The universe could therefore contain enormous black holes drifting between galaxies, carrying millions of solar masses while leaving almost no visible trace. But this discovery may have revealed another important clue. Astronomers have also found evidence for black holes located away from the centers of galaxies. Some may have been displaced through gravitational interactions. Others could potentially have formed in unusual environments. One possibility being investigated is direct collapse, where a massive gas cloud collapses directly into a black hole instead of first forming ordinary stars. If such objects can form outside normal galactic centers, it would expand our understanding of where black holes can exist and how they are created. There is another fascinating way astronomers can search for wandering black holes. Instead of looking for the black hole itself, they can look for what happens when it interacts with a star. If a black hole passes close enough to a star, its immense gravity can tear the star apart. This creates a tidal disruption event. If such an event happens far from the center of a galaxy, astronomers have to consider the possibility that the culprit is a wandering black hole. That gives researchers another method for finding these otherwise invisible objects. And this is why the discovery of one candidate is so important. Once astronomers know what the signature looks like, they can begin searching for more. Future observatories and large-scale sky surveys could reveal many additional examples. The Roman Space Telescope, along with powerful ground-based observatories, will help astronomers survey enormous regions of the sky and search for unusual stellar trails, displaced black holes, and tidal disruption events far from galactic centers. This could completely change how we think about the relationship between galaxies and their central black holes. For a long time, astronomers treated the supermassive black hole at the center of a galaxy as a fundamental part of the galaxy's structure. But if black holes can be kicked out, then that relationship is not permanent. Galaxies can lose their central black holes. Black holes can travel outside galaxies. And the evolution of galaxies may be even more violent and complicated than our models suggest. There is also something deeply strange about the stellar trail itself. The black hole may be triggering star formation as it moves through gas. That means the object responsible for creating this extraordinary trail is not necessarily destroying everything in its path. It may actually be helping create new stars. Gas gets compressed. Clouds collapse. Stars ignite. And over millions of years, some of those stars could develop their own planetary systems. All because an enormous black hole was moving through the wrong place at the right, or perhaps the wrong time. That is one of the most remarkable aspects of this discovery. A violent gravitational event can produce something beautiful. A black hole can be expelled from a galaxy, and the trail it leaves behind can become a stellar nursery. The universe has a strange way of turning destruction into creation. An RBH1, or the runaway black hole candidate associated with this extraordinary trail, may be showing us exactly that process. There is also an important scientific lesson here.